Welcome to the DIY Honda Garage channel. Welcome to this detailed troubleshooting guide for DTC P0366, indicating a mismatch in phase detection between the CMP, Camshaft Position Sensor B, and CKP, Crankshaft Position Sensor. This guide pertains specifically to the Honda Civic models from 2016 to 2021. It is important to approach this diagnostic code methodically, ensuring all steps are followed closely. Each component plays a critical role in the overall function of the engine management system, and understanding their locations and interactions is vital for effective troubleshooting. The CMP sensor monitors the position of the camshaft, while the CKP sensor checks the position of the crankshaft, sending this information to the Powertrain Control Module, PCM, which adjusts timing accordingly. In cases where both sensors indicate abnormal readings, it can lead to engine performance issues, which necessitates a thorough analysis using the provided guidelines. DTC P0366 signifies the malfunction of the camshaft position sensor B in conjunction with the crankshaft position sensor, indicating an incorrect phase detected between them. The CMP sensor B is primarily situated near the camshaft in the engine compartment, while the CKP sensor can be found near the crankshaft on the engine block. These sensors are essential for delivering precise timing information to the PCM. When the PCM receives conflicting signals from these sensors, it indicates a phase mismatch, leading to potential engine performance issues such as misfires or stalling. The condition can be acute or intermittent, depending on the underlying cause. Therefore, it is crucial to address this issue immediately, as neglecting it could lead to more extensive engine complications. There are several possible causes for DTC P0366. It may stem from faulty sensors, either the CMP sensor B or CKP sensor, which can become defective over time or due to environmental stressors. Additionally, poor wiring connections or damaged wires leading to these sensors can disrupt the electrical signals they transmit, causing miscommunication with the PCM. Issues within the variable valve timing (VTC) system, which manages engine timing, can also lead to this error. If the VTC oil control solenoid valve has failed, or if there is a blockage, it can prevent the system from functioning correctly, contributing to the phase misalignment. Finally, mechanical issues within the engine, such as a stretched cam chain or a misaligned camshaft, can cause the same DTC. When DTC P0366 is present, several symptoms may manifest in your Honda Civic. One of the most common indicators is an engine misfire, which occurs when the engine's timing is off, leading to incomplete fuel combustion. You might also experience poor acceleration as the engine struggles to produce the power it normally would, resulting in sluggish performance. Another common symptom is the illumination of the check engine light on your dashboard, alerting you to the presence of a fault code. Other potential symptoms can include rough idling or stalls while driving, which directly relates to the failure of the CMP and CKP sensors to provide accurate position data. Addressing these symptoms promptly is vital to avoid further damage to the engine's internal components. The first step in troubleshooting DTC P0366 is to turn the vehicle to the on mode without starting the engine. This allows the onboard diagnostic system to initialize. Utilizing the HDS Honda Diagnostic System, clear the DTC. After clearing, turn the vehicle off and allow the engine to cool below 104 degrees Fahrenheit or 40 degrees Celsius, which is crucial to prevent overheating. Then, start the engine and let it idle without any load, ensuring that the engine is running in a controlled state. Finally, check for any pending or confirmed DTCs again with the HDS to verify whether DTC P0366 has reappeared. This initial assessment helps determine if the issue is persistent or intermittent, and sets the foundation for subsequent troubleshooting steps. In the second troubleshooting step, we check the variable timing control (VTC) system. Using the HDS, navigate to the inspection menu and select the VTC test option, followed by EX-VTC, external VTC. This test will provide insight into the performance of the VTC system and its adjustments. After performing the test, analyze the results displayed on the HDS. If the result is acceptable, you will move to the next step. Otherwise, you will proceed to check for more extensive issues, such as wiring problems or component failures, which might be causing the incorrect phase detected DTC P0366. Properly diagnosing the VTC system is crucial, as it directly influences the engine's overall timing capabilities. Step 3 involves performing a test drive of the vehicle. Drive steadily at speeds between 19 to 38 miles per hour, 30 to 60 kilometers per hour, for approximately 10 minutes, which effectively allows the engine and the VTC system to reach an optimal operating state. During this drive, you will monitor specific parameters via the HDS, including the EX-VTC status, signal thresholds, and current condition values. This data gathering is essential to determine if the current conditions match established thresholds. If they do, this indicates that the VTC system is functioning correctly at this stage. However, if the results show discrepancies, a deeper investigation will be required, possibly including another test drive, ensuring all parameters are correctly checked and operational. For the fourth troubleshooting step, you will monitor the OBD, onboard diagnostic status, using the HDS. This involves checking the DTCs menu for the presence of DTC P0366. If the system indicates failed, this confirms that there is an ongoing issue and you will continue your troubleshooting process as outlined. However, if the HDS indicates passed or reveals an intermittent failure, it suggests that the problem may not be consistent at this moment. In such a case, if an onboard snapshot of the DTC exists, try to replicate the conditions under which the failure occurred to see if it can be reproduced. If the status indicates not completed, it will be essential to revisit and recheck the VTC status to ensure no other underlying issues persist. In this fifth step, you will perform an operational check on the VTC oil control solenoid valve B. This component controls the flow of oil to the VTC system, allowing for proper timing adjustments. If the solenoid valve functions correctly, you will proceed to the next troubleshooting step. However, if the solenoid is found to be faulty, it will need to be replaced as it is critical for the VTC system's operation. Faulty operation of this valve can lead to incorrect phase detection, causing the DTC P0366 to trigger. Therefore, thoroughly testing this solenoid is essential to determine the health of the VTC system and to rule out this potential issue. The sixth troubleshooting step involves checking the camshaft timing. Camshaft timing is critical for synchronizing the opening and closing of the engine's valves in relation to the crankshaft's position. If the camshaft timing is incorrect, it can directly lead to DTC P0366 being activated, as the sensors may not be able to detect the correct phase. Use appropriate tools and methods to verify that the camshaft timing is set within manufacturer specifications. If any discrepancies are identified, you will need to reset the camshaft timing to ensure it aligns harmoniously with the crankshaft. Correct timing ensures the engine operates smoothly and efficiently, minimizing the risk of further complications. In Step 7, focus shifts to the cam chain. which plays an integral role in maintaining the proper timing of both the camshaft and crankshaft. Inspect the cam chain for any signs of damage or stretching, as these conditions can severely impact the vehicle's timing precision. A stretched or damaged cam chain may cause the sensors to read the timing incorrectly, directly relating to the DTC P0366 issue. If any problems are detected during the inspection, the cam chain and the auto tensioner must be replaced to restore proper timing. Furthermore, ensuring a functioning cam chain system is crucial for overall engine health and reliability. This diligence will help prevent significant engine troubles down the line. The eighth step involves inspecting VTC Actuator B, which is responsible for adjusting the camshaft timing as it relates to the crankshaft. This actuator must function properly in order to effectively manage the variable timing system. During the inspection, verify that the actuator operates correctly and meets the system's specifications. If the actuator is malfunctioning or not operating as intended, it will need to be replaced to prevent any further issues with timing adjustments. Proper functionality of the VTC actuator is essential, as it directly influences the engine's performance and efficiency. Ensuring this component is functioning optimally can mitigate future problems associated with incorrect phase detection. In the final step, conduct a comprehensive check of the PGM-FI, Programmed Fuel Injection System. Begin by switching the vehicle to the on mode while ensuring that no load is applied. Use the HDS to reset the PCM, Powertrain Control Module, recalibrating the vehicle's electronic systems for optimal function. Following this, it is crucial to perform the CKP, Crankshaft Position, Pattern Clear procedure. Then proceed with the PCM Idle Learn and CKP Pattern Learn procedures. This sequence ensures that the engine control modules can accurately learn and adapt to the conditions of your vehicle. Once completed, idle the engine without any load and conduct a final check with the HDS for any pending or confirmed DTCs, ensuring that DTC P0366 is resolved and not reappearing. Upon completing all troubleshooting steps for DTC P0366, it is vital to verify the repair. Begin by checking all connections and wiring terminals associated with VTC Oil Control Solenoid Valve B and the PCM to ensure they are secure and damage-free. Any loose or poor connections can disrupt signals, leading to erroneous DTCs. If everything appears intact and functional, confirm that the system operates as expected without any interruptions. If the DTC has been resolved, ensure to clear the codes from the system using the HDS. This final verification step is crucial for ensuring the long-term reliability and performance of your Honda Civic, allowing you to drive confidently, knowing the issue has been adequately addressed. Preventive maintenance is key in avoiding the recurrence of DTC P0366 and ensuring optimal engine performance. Regular inspections of the VTC system components, including the VTC oil control solenoid and actuators, can help identify issues before they escalate. Additionally, monitoring sensor health can prevent long-term damage, as early detection of sensor malfunctions allows for timely replacements. It is also advisable to follow the manufacturer's recommended service intervals for oil changes and timing component inspections, as the internal lubrication can greatly affect the life expectancy of the timing chain and associated components. By incorporating these practices, you will not only enhance the reliability of your vehicle, but also preserve its performance for years to come. In conclusion, understanding the components and their interactions within the engine management system is crucial for effectively diagnosing and resolving DTC P0366, which indicates a phase mismatch between the CMP sensor B and CKP sensor. Following the outlined diagnostic steps allows technicians to systematically identify and rectify underlying issues, whether they stem from sensors, wiring, or mechanical failures. It's essential to verify repairs thoroughly and commit to preventive maintenance practices to mitigate similar issues in the future. By maintaining vigilance and adhering to proper service intervals, you can ensure the longevity and reliability of your Honda Civics engine, keeping it running smoothly and efficiently. Please like and subscribe to the channel. See you next time.